Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to learn about proof of irrational numbers from the chapter real numbers. Very important topic. Every time he is asking 4 marks from this area, proof of irrational numbers. He gives an irrational number, he asks prove that it is an irrational number. Definitely you can get 4 marks problem from this exercise 1.4. So totally we have in the first question there are 5 bits and there is a second question. Totally we have 6 irrational numbers, proof of irrational numbers. Very important. Definitely we can get 4 marks problem from this exercise. Okay, so see here, how can we prove? Before that we have to learn about the definition. We have to just recall the definition of irrational numbers. What are the irrational numbers? So the numbers which cannot be converted into p by q form are called irrational numbers. So p comma q are integers and q is not equal to 0. So see here, the numbers which cannot be converted into p by q form. So here q is not equal to 0, p comma q are integers, are called irrational numbers. So these are irrational numbers are denoted by q star or q prime. So examples root 2, root 3, root 5, etc. And pi is also an irrational number. Next, non-terminating, non-repeating decimals are irrational numbers. 13.201304 and so on. So dash. It is non-terminating, non-repeating decimal. It is also an irrational number. So now we have to prove the given numbers are irrational numbers. So now we have to solve problems from exercise 1.4. This is the first problem in the exercise 1.4. See here what he is asking. Prove that the following are irrational numbers. So this is the first bit, 1 by root 2. So in the first problem totally we have 5 bits. This is the first bit, 1 by root 2 he has given. We have to prove that 1 by root 2 is an irrational number. So here we use indirect method to prove. So first let the given number be rational number. So here we know every rational number can be written in the form of a by b. So see here, first this is the first step. So let us assume on the contrary that 1 by root 2 is a rational number. So this is the first step. So all problems are related to similar one and another. So if you understand one problem clearly, you can do each and every problem. Suppose if you do only 2-3 steps, you can get some marks. So you need not to complete total problem if you don't know. If you know, you can proceed. So here every step has some mark. So see here, this is the first step. Let us assume on the contrary that 1 by root 2 is a rational number. If it is rational number, it can be written in the form of a by b. Therefore we can write 1 by root 2 is equal to 1 by root 2 is equal to a by b, where a comma b are co-primes. A comma b are co-primes and b is not equal to 0. A comma b are co-primes, b is not equal to 0. B are co-primes and b is not equal to 0. So here by cross multiplication, see here what we get. By cross multiplication, 1 into b is equal to root 2 into a. That is b is equal to root 2 into a. So by squaring on both sides, what we get? By squaring on both sides, on the left side we have b. So if we square, it becomes b square is equal to, on the right side we have root 2a. So by squaring we can get root 2a whole square. So see here what it is. B square is equal to, so root 2 square is 2 and a square. B square is equal to 2a square. Let it is equation number 1. So here b square is a multiple of 2, there we can write 2 divides b square. Since it is a multiple, it is a factor, so we can write 2 divides b square. Therefore we can write so we can write 2 divides b square. Since 2 is a multiple of b square, then we can write 2 divides b square. If 2 divides b square, we can say 2 divides b also. We have one proven statement. If 2 divides b square, we can write 2 divides b also, b. So 2 divides b, then we can write b is equal to, then 2 divides b, then we can write b is equal to 2 into some c. Here c is a constant, c is an integer, c is some integer. So here b is equal to 2 into c, c is an integer. So by squaring on both sides, again what we get, c here. So by squaring on both sides, on the left side we have b is equal to, so that is it becomes b square. On the right side 2c is there, it becomes a 2c whole square. So see here, instead of b square I am writing 2a square from equation 1. So I am writing, instead of b square I have written 2a square. Since from equation b square equal to a square, so I have written 2a square. It is 2c whole square is 4c square. So since from equation 1, I have written b square equal to 2a square. So here a square is equal to 4c square divided by 2. Take 2 to the right side, here it is multiplying, it divides 2 ones and 2 twos. So that implies we can write a square is equal to 2c square. A square is equal to 2c square. So here also a square is also multiple of 2. We have a square is equal to 2c square. Here a square is the multiple of 2, hence 2 is a factor of a square, then we can say 2 divides a square. That implies 2 divides a. If 2 divides a square, that implies 2 divides a. This is the proven statement. So therefore a and b have 2 as common factor. So we have 2 divides b and 2 divides a. 2 is a factor of a and 2 is a factor of b. Therefore a and b have 2 as common factor. But this contradicts our assumption that a and b are co-primes. In the very first starting, we thought that a and b are the co-primes, but co-prime means there are no common factors. But here a and b have 2 as common factor. This arises because of our wrong assumption. What is our wrong assumption? 1 by root 2 is a rational number. That is, our assumption is wrong. Hence we can decide that 1 by root 2 is irrational. So like this we can prove 1 by root 2 is irrational. So this is the first bit in the first problem. So next we have to solve second bit. This is second bit in the first problem. So here he has given root 3 plus root 5. Prove that the following are irrational. So we have completed first one. This is second bit, root 3 plus root 5. So we have to prove that root 3 plus root 5 is an irrational. So for that, first we have to assume that root 3 plus root 5 is a rational number. So let us assume on the contrary that root 3 plus root 5 is a rational number. If it is a rational number, it can be written in the form a by b. So I am writing. So root 3 plus root 5 is equal to. So if it is a rational, every rational number can be written in the form a by b. So here since root 3 plus root 5 is rational number, it is also written in the form a by b. Root 3 plus root 5 is equal to a by b, where a comma b are integers and b is not equal to 0. So now see here, just you have to simplify here, right, root 3 is equal to, so taking root 5 to the right side, a by b, so plus root 5 becomes minus root 5. So now by squaring on both sides, what we get, see here. So by squaring on both sides, on the left hand side we have root 3. So root 3 whole square is equal to, on the right hand side we have a by b minus root 5 whole square. So it is root 3 whole square, we get 3 is equal to. So it is in the form a minus b whole square. A minus b whole square is a square minus 2ab plus b square. So a square is a by b whole square. A by b whole square minus 2ab is 2 into a by b into root 5 plus b square is root 5 whole square. Root 5 whole square. So just I have expanded using a minus b whole square. So now further I have to simplify. So see here what we get. So on the left hand side 3 is there. Write 3 as usual. 3 is equal to, so a by b whole square, it becomes a square by b square. A by b whole square is a square by b square minus it is 2a by b into root 5. 2a by b into root 5 plus root 5 whole square is 5. Root 5 whole square is 5. So now I am taking this total term to the left side and 3 to the right side. So what we get, I am writing, see here. So minus 2a by b into root 5 is there. It becomes plus 2a by b into root 5 is equal to. Here already a square by b square is there. I am writing a square by b square as usual. So here plus 5 is there. And this plus 3 becomes minus 3. So just we have to simplify. See here again further. So 2a by b into root 5, right as usual. So this 2a by b into root 5 is equal to here a square by b square. So 5 minus 3 is plus 2. 5 minus 3 is plus 2. So again see here 2a by b into root 5 is equal to. So here a square, find LCM, a square plus 2b square divided by b square. So here find LCM, a square plus 2b square divided by b square. Now take this 2a divided by b, this term to the right side. So on the left side only root 5 will be. So root 5 is equal to, so here a square plus 2b square by b square is there. A square plus 2b square by b square into. So 2a by b becomes b by 2a. So just you have to write the reciprocal, b by 2a. So b gets cancelled. So we can get here finally root 5 is equal to a square plus 2b square divided by 2ab. So here root 5 is equal to a square plus 2b square divided by 2ab. Just what are a and b? A and b are the integers. So here a square plus 2b square divided by 2ab, here we can get the rational number. It is also integer. So but it is equal to root 5. So see here how can we write. Finally we have root 5 is equal to a square plus 2b square by 2ab. So since a comma b are integers, a square plus 2b square by 2ab is rational. So here root 5 is rational. But this contradicts the fact that root 5 is irrational. So see here how can we write. Since a comma b are integers, a square plus 2b square divided by 2ab is rational. So if it is rational, it is equal to root 5. So root 5 is rational, but this contradicts the fact. That root 5 is irrational. So here we can decide, hence root 3 plus root 5 is irrational. So we can decide that hence root 3 plus root 5 is irrational. So very important and very easy. So each problem, we have totally 4 bits in the first problem and there is second problem. So each and every problem has a similar steps. If you learn one problem, you can do all. So just you have to remember the steps. So this is the second bit. Next we have to solve third bit. This is the third bit in the first problem. Prove that the following are irrationals. Third bit 6 plus root 2 is given. So let us assume on the contrary that 6 plus root 2 is a rational number. First we have to assume that it is a rational number. So every step, every bit has this first step, same first step, that simply how to write. Every bit has the first step, same like this. Let us assume on the contrary that 6 plus root 2 is a rational number. If it is a rational number, every rational number can be written in the form a by b. Therefore, we can write 6 plus root 2 is equal to 6 plus root 2 is equal to a by b. So, where a comma b are integers, and b is not equal to 0. So 6 plus root 2 is equal to a by b, where a comma b are integers, b is not equal to 0. So just see here what I am doing. Take 6 to the right side. On the left hand side we have root 2 is equal to a by b plus 6 becomes minus 6. So write a root 2 as usual. Find LCM. So here a minus 6b divided by b, a minus 6b divided by b. So it is very easy. So here a comma b are the integers, hence a minus 6b by b becomes irrational. So if it is rational, so root 2 is rational, but this contradicts the fact that root 2 is irrational, hence we can say 6 plus root 2 is irrational. So see here how can we write. Since a comma b are integers, a minus 6b by b is irrational. So root 2 is rational. But this contradicts the fact that root 2 is irrational. Therefore we can write, but this contradicts the fact I am writing here only. But this contradicts the fact that root 2 is irrational. Therefore we can say hence. Therefore, we can say hence 6 plus root 2 is irrational. So, very important and very easy. So, just you have to remember the steps. All the steps in all bits are similar. If you learn perfectly, only one you can do, remaining all very easily. So, this is the third bit. Next, we have to solve fourth bit. This is the fourth bit in the first problem. Already we have completed first, second and third. See here it is root 5. So we have to prove that root 5 is an irrational number. So for that let us assume on the contrary that root 5 is a rational number. First we have to think that it is a rational number. So if it is a rational number, we know every rational number can be written in the form a by b. So therefore root 5 is equal to a by b, where a comma b are co-primes and b is not equal to 0. So now we have to simplify. See here by cross multiplication we can get root 5 into b is equal to s. Root 5 into b is equal to a. So by squaring on both sides, so what we get, first I am writing a square is equal to, so next I am writing root 5 into b whole square. So that implies we can get a square is equal to root 5 whole square is 5 and b square. A square is equal to 5b square. Let it is equation number 1. So a square is a multiple of 5. So we can say that 5 divides a square. 5 divides a square. 5 divides a square. If 5 divides a square, then 5 divides a also. We have one proven statement. Using that we can say if 5 divides a square, then 5 divides a also. 5 divides a. 5 divides a. So see here, if 5 divides a, so a can be written in the form 5 into some integer c. So here c is an integer. C is an integer. So see here. Again by squaring on both sides, so what we get, see here, by squaring on both sides. By squaring on both sides, on the left hand side we have a square. A is there. By squaring we can get a square is equal to 5 into c is 5c whole square. 5c whole square. So just we have to simplify further. A square is equal to 5c whole square is 25c square. 25c square. So here we have from equation 1 a square is equal to 5b square. So instead of a square I am writing 5b square. So 5b square is equal to 25c square. 25c square, since from equation 1. Since from equation 1. So just see here, take 5 to the right side, we can get b square is equal to 25c square divided by 5. So just take 5 to the right side, here it is multiplying, it divides. So 5 one side, 5 5. So finally we have b square is equal to 5c square. B square is equal to 5c square. So b square is also a multiple of 5. So here we can say that 5 divides b square again. Therefore 5 divides b square. 5 divides b square. If 5 divides b square, that implies 5 divides b also. 5 divides b. 5 divides b. So here 5 divides a means 5 is a factor of a, and 5 divides b means 5 is a factor of b. Therefore 5 is a common factor of a and b. So at the very starting we say that a and b are co-primes. So co-primes means they have no common factors. But here we have a common factor 5. So this arises because of our wrong assumption that root 5 is rational. Therefore we can say that root 5 is not rational, it is irrational. So see here how can we write. So therefore we can write both a and b have 5 as a common factor. But this contradicts the fact that a and b are the co-primes. But this contradicts the fact that a and b are co-primes. This arises because of our wrong assumption. Therefore we can say that this is arisen because of our wrong assumption. Therefore we can say that root 5 is not rational, it is irrational. Root 5 is irrational. So like this we can prove. This is the fourth bit in the first problem. Next we have to solve the fifth bit. This is the fifth bit in the first problem. It has given 3 plus 2 root 5. We have to prove that 3 plus 2 root 5 is irrational. So again the same steps we have to follow. So just see here. Let us assume on the contrary that 3 plus 2 root 5 is a rational number. So it is say this same step we can return for all the problems for proof of irrational numbers. So just you have to remember the steps. So let us assume on the contrary that 3 plus 2 root 5 is a rational number. So just student you have to remember that every step has some marks. So you don't think that if we completely do then we get marks. You don't think like that. If you stop it here, you can get at least 1 mark. So you have to follow the steps. See here, if it is a rational number, first we have to assume that the given number is irrational. So we can say that every rational number can be written in the form a by b. Therefore 3 plus 2 root 5 is equal to a by b, where a comma b are integers and b is not equal to 0. So just we have to simplify here. 3 plus 2 root 5. Take 3 to the right side, we can get 2 root 5 is equal to a by b minus 3. Plus 3 becomes minus 3. So just take 2 to the right side again. So before that, see here 2 root 5 right as usual is equal to, find LCM. So it becomes a minus 3b divided by b. So 2 root 5 is equal to a minus 3b divided by b. Now take 2 to the right side, we get root 5 is equal to, so a minus 3b divided by 2b. 2 is multiplying here, it divides. So again here a comma b are integers, therefore a minus 3b divided by 2b becomes irrational. So if it is rational, so root 5 is rational. But this contradicts the fact that root 5 is irrational. Hence 3 plus 2 root 5 is irrational. So that you have to remember. So root 5 is equal to a minus 3b divided by 2b. Therefore, since a comma b are integers, a minus 3b divided by 2b is rational, so root 5 is rational. But this contradicts the fact root 5 is irrational. So therefore we can write but this contradicts the fact that root 5 is irrational. Hence 3 plus 2 root 5 is irrational. Therefore we can write hence 3 plus 2 root 5 is irrational. So this is the fifth bit in the first problem. Totally we have 5 bits. All the 5 bits we have completed. So next we have to solve the second problem. So see, so this is the second problem in the 1.4 exercise. Already we have completed first problem. There are 5 bits in the first problem. This is a second problem. See here what he is asking. Prove that root p plus root q is an irrational where p comma q are primes. So here root p plus root q has given. He is asking to prove that it is an irrational number. So for that, first let us assume that root p plus root q is a rational number. So let us assume on the contrary that root p plus root q is a rational number. So if it is a rational number, every rational number can be written in the form a by b. Hence root p plus root q is equal to a by b, where a comma b are integers and b is not equal to 0. So next we have to simplify. Just I am taking root q to the right side. What we get? On the left side we have root p is equal to a by b minus root q. A by b minus root q. So by squaring on both sides, on the left hand side we have root p. So it is root p whole square is equal to, on the right hand side we have a by b minus root q whole square. So here root p whole square we can get p is equal to, so it is in the form a minus b whole square. So here a square minus 2ab plus b square. A square is a by b whole square minus 2ab is minus 2 into a by b into root q plus b square is root q whole square. So see here again you have to simplify further. Write p as usual on the left hand side. it is a by b whole square. We can write a square by b square, a square by b square minus write 2a by b into root q as usual, 2a by b into root q plus here root q whole square is q, root q whole square becomes q. So now take this negative term to the left side and p to the right side. So what we get, I am writing here, see here. So minus 2 into a by b root q, it becomes positive. So 2 into a by b into root q. So this total negative term becomes positive if you take to the left side. So here already what is there on the right side? A square by b square is there. So here plus q is there, plus q, and take this plus p to the right side, it becomes minus p. So now we have to simplify further. Write this left hand side term as usual, 2 into a by b into root q is equal to, so find LCM, a square plus q minus p into b square, it is q minus p into b square divided by b square. So treat this total term as q minus p. So a square plus b square into q minus p divided by b square. Now take 2 into a by b to the right side again. So we have only root q on the left hand side. Root q is equal to, so what is there here? A square. Root q is equal to a square plus q minus p into b square. A square plus q minus p into b square divided by b square into, so this 2 into a by b becomes b by 2a. What it is? B by 2a. It becomes b by 2a. So here b and square gets cancelled. Finally we can get root q is equal to a square plus q minus p into b square, a square plus q minus p into b square divided by 2ab, 2a into b, 2ab. So now see here, root q is equal to a square plus q minus p into b square divided by 2ab. So since a and b are co-primes, see here, integers, a and b are integers and p comma q are primes. Therefore, a square plus q minus p into b square divided by 2ab becomes irrational. So, root q is rational. But this contradicts the fact that root q is irrational. So, we can write like this. Since, see here, since a comma b are integers and p comma q are primes, a square plus q minus p into b square divided by 2ab is rational. So if it is rational, so root q is rational, but this contradicts the fact root q is irrational since q is prime. Therefore, we can say that root p plus root q is irrational. See here, how can we write? See here, but this contradicts the fact that root q is irrational. This is arisen because of our wrong assumption. Therefore, we can say that root p plus root q is irrational. So, like this, we can proof of irrational. So, very important. So this is the second problem in the 1.4 exercise. We have completed all problems in 1.4 exercise. That's all today's class. We will meet in the next class with another problem. Thanks for watching.